Creating the first affordable AR headset experience. Using Google Cardboard, I made the first AR headset experience that does not rely on expensive, specialized hardware. By reconstructing and rendering the user's surroundings in VR, the AR Multi-Pendulum app replicated Microsoft HoloLens. The process of creating the app involved heavy optimization for power efficiency and fixing bugs caused by using a GPU for general-purpose tasks. The final product was AR Headset Kit, a high-level open-source framework for creating AR headset experiences. Augmented reality, or AR, is a technology that blurs the boundary between real and virtual, rendering computer-generated objects that interact with the real world. In the late 2020s, smart glasses will use AR to provide new forms of human-computer interaction, eventually replacing smartphones. At the moment, someone can use HoloLens to preview the experience of using smart glasses, but it costs $3,000, which the average person cannot afford. Purpose of my research: allow someone to experience what smart glasses will be like without paying thousands of dollars. Using already existing hardware, create a fluid AR headset experience. The experience will include real AR, stereoscopic rendering, and virtual objects controlled through hand gestures. It should be widely accessible so that any person can try it. Research question: can Google Cardboard, a VR headset, be used as an AR headset? Materials: Mac Mini, iPhone, and Google Cardboard. Google Cardboard turns an iPhone into a VR headset. Acquiring the hardware is the easiest part. Creating the software is what takes the most time. Procedure: first, build a general-purpose 3D rendering engine for basic virtual objects. It supports different colors and shapes. Then, track and reconstruct the user's hand to bring it in front of virtual objects. Render two-dimensional text on 3D surfaces. Correct for light distortion in the VR headset. And add color to 3D scans of the environment. Challenges: AR apps require a massive amount of power. When an iPhone overheats, iOS throttles performance. The thermal state starts at a nominal, which is what an iPhone normally is in. When it goes under increased thermal strain, it transitions to fair. And when it's serious, iOS drops the frame rate from 60 to 30 frames per second. This causes VR sickness. So, an app must stay in the fair thermal state for as long as possible. Optimizing for power efficiency requires very complex algorithms which are prone to bugs. In the top left, the orange mesh should be my personal computer, but it is corrupted. In the bottom left, an app prototype crashes while rendering to the screen, creating a lot of pink pixelated squares. In the top right is an early attempt at adding color to 3D scene reconstruction. In the bottom right, part of the pendulum is missing when simulating motion blur. This bug still exists in AR Multi-Pendulum. Results: successful emulation of smart glasses. Provides a fluid user experience at a consistent 60 frames per second, lasting over 15 minutes. Uses a 3D scanner with a standard RGB camera to reconstruct reality in VR in real time. 2 products: AR Multi-Pendulum, an iOS app that puts a physics simulation into AR, and AR Headset Kit, which lets software developers create AR headset experiences. Conclusion: While AR Headset Kit does not fully replicate HoloLens, it allows people to interact with virtual objects in a simulated representation of their surroundings. As a result, they can experience what AR headset technology is capable of firsthand without waiting for the smart glasses revolution to happen. In 2023, Apple is expected to release its first AR/VR headset. Although very expensive, many more developers will create software for Apple's headset than AR Headset Kit. AR Headset Kit will remain the cheapest and most accessible way to experience an AR headset, even though few people use it.